Hi guys, welcome back to my YouTube channel. And today I'm up with the next question of top 150 interview questions of Lead Code climbing stairs. So let's get started with the same. So you are climbing a stairs. It takes n steps to reach the top. Each time either we can climb only one step or two steps. So we have to figure out in how many distinct ways we can climb to the top. So So suppose if you are having three steps at a time to climb. So in how many different ways we can climb three steps? So the basic condition that we are given at the time is either we can, so in order to cover up the flight of three steps as per the question, either we can climb one stair at a time, or either we can climb two stairs at first instance and one stair at last, or we can climb only one stair during the first time and the next two stairs at last. So in total we are having three ways to climb three stairs. So so after going through this question, what we can simply figure out. So it means either we can climb two steps at a time or we can climb only one step at a time. So what does it mean? So whenever we are trying to climb only one step, so whenever we are trying to climb only one step, so whenever my n is equal to 1, what does it mean? So it simply implies that we can only climb one stair using one method. So that's what the point is. So suppose I have two stairs at a time. Suppose I have two stairs at a time. So in how many ways can I climb two stairs? So either I can climb one by one in order to reach the top, either one or one, or what I can simply do, I can simply climb two stairs at a time. So whenever I have my n is equal to 2, my resultant output would be 2. That's what the question states. So what we are actually trying to achieve in this question. So we are trying to find out the number of distinct ways by reducing the count to 1. So that's what the thing is. So that's what the question states. So what we are actually trying to do in this question, we are actually trying to reduce our count to 1. So whenever I have three steps at a time, so either I can climb two steps or one step. So if I climb two steps, either I can climb at a time one step. So if I climb two steps, either I can take a flight of two steps at a time, or I can take a single step at a time. So whenever, so not talking about one step. So whenever I climb one step, so it means I've already covered one step at a time. So what I'm left with, either I can climb the remaining two steps in one go, or either I can climb the remaining two steps in one at a time. So that's what I wanted to state over here. So let me just repeat this concept once again. So whenever I'm having three stairs, so let me just make a drawing of three steps over here. So it's better to be, so that it's better to visualize the thing. So whenever I climb three steps at a time, so what I can actually do in this case, either I can climb two steps. So let me draw one more drawing where I am assuming that I have climbed two steps at a time. So suppose I have already climbed, so suppose I'm already standing over here. I've climbed two steps. So what are the remaining steps that I have to climb? I think the good answer is that we are having only one step to climb over here. So one of my possibility, so my first possibility is already done. So now let's talk about the another possibility. That is when I think of climbing only one stair at a time. So the only one stair that I took is already done, correct? So how many stairs I'm left with? I'm left with two stairs. So as per the rule of the game, as per the rule of climbing the stairs, according to question, what I can simply assume, either I can climb these both of these steps at once in order to reach the top, either I can just simply jump over here, or either I can take one by one step. So the total number of combinations that I cover is two. So what do you think? Is it something like recursion? I think the answer is yes. Why so? Because what we are actually trying to achieve in our recursive call is that whenever I am left with only one stair, I have to climb only once. That's what the rule states. Or either, so so what does it mean? So either I can climb only n minus one stair, uh, either I can climb only one stair, or I can climb only two stairs. So so how many stairs are left if I have n stairs? If I climb only one stair at a time. So I'm only left with n minus 1 stairs. If I climb two stairs at a time, so I'm only left with n minus 2 stairs. And this recursive tree will go on and ultimately will reach 1 as the last value. So what would be my possible recursive function for this? So my possible recursive function for this would be something like, I'll be returning something like func. I'll be passing my n to it, and if so, what will be the base case? If whenever my n is equal to 1, so it means we can only climb one stair using one method, one distinct way. Or else what I will return from this is func of n minus 1 plus func of n minus 2. That is all I have to do in this question, and my question is done. So what is the overall time complexity of this problem? It turns out to be big of 2 raised to power n, because we are actually working in the recursive method, right? Because in this case what is happening is doing multiple we are doing multiple tasks, multiple repeated tasks. That's what the question is. And space complexities of n, because we are using the auxiliary stack space. But do you think it a better solution? I think the answer is no. So we can simply memorize this solution. We can What we can do is we can simply just memorize it. Uh, if my n is equal to 1, I'll simply return 1 because my base case remains as it is. And if my n is not equal to 1, I'll simply return my dp of n minus, I guess it's n only. Yeah, it would be n, because, and what I'll be actually returning from my function is dp of n minus 1 plus, uh, wait a minute. So I'll be storing my result dp of n minus 1 in func of n minus 1, and dp of n minus 2 would be storing the result of func of n minus 2, and I'll return their sum. So this is one of the basic solution that I can actually think of while memorizing the same. So this is one of the possible solution that I can think while memorizing my problem. So that's what the uh, basic statement of this problem, guys. And here dp of 0 will be 0, dp of 1 will be 1, and dp of 2 will be 2. Because why I'm taking of 2 is because I have assumed that 2 is my base case, because we can either, whenever we are having two stairs, either we can climb all the two at the same time, or we can climb them one by one. So this is one of the solution that we get. But I don't think that in an interview you need to waste a lot much time while discussing all of these approaches. Rather, you can just simply skip this memoization step. Maybe if, and we can just jump on to the optimal solution for this problem, which involves dynamic programming using um, bottom up approach. Like, we are basically starting from 1 and we'll be moving till n. We are starting from 1 and we'll be moving till top. That's what um, I'll actually use while optimizing this solution. So what all we have to do while optimizing this solution? Simply we need to take a div array, initialize it till n. Let me assume that my 0th index, or what we can do, we can simply take it till n plus 1, because what I'm assuming is that whenever I have zero number of stairs, I have zero distinct ways to climb a stair. So whenever I have number of stairs to be 1, I have only one way to climb, and whenever I have number of stairs as 2, I only have two ways to climb the stairs. And I'll be proceeding from uh, 3 to n, where I'll be simply adding my dp of I is equal to dp of I minus 1 plus dp of I minus 2. Because in either of the case, either we can take steps one by one, or we can take two steps at the same time. So there is an either or. So that's why we are summing up the situation, and then we'll simply return our dp of n. So my final value will actually store the answer. So this is what is all about the dynamic programming using bottom-up approach. Uh, that's what the say time. And the time complexity turns out to be big of n, and the space complexity turns out to be big of n, because we are actually using an auxiliary array. So let's move to the code of this problem. So we are simply just moving from 1 to n. And what we can, as I've already covered my base case in this, like whenever my n is equal to 1, I will simply return 1. So no need to go up till in all of these calculations. So we can simply assume that we'll be traveling from n plus 1. Why I'm taking n plus 1? Because I am considering 0 as 0. 0 means that there are 0 stairs, so it means that there are 0 ways to climb over it. And whenever I have a stair, I'm standing on a stair. Either we can reach that stair using one by one steps, or either we can climb two steps at a time in order to reach that stair. And I'll simply return my n value. So let's run this code. It works fine, and now let's submit it. So so I think it's a good sign that our solution beats 100%. So I hope, guys, you you have understood this question. If you have understood, please to hit the like button, and if you are new to the channel, please to subscribe. And I request all of you to please share my channel with your peers, your friends, or your colleagues if you're working. That actually motivates me a lot to make more such content. Thanks a lot, and keep watching my channel.